Dear everybody, the title of this presentation is Relative Effectiveness of Direct Instruction versus Active Learning in the Teaching of Science. This research was realized by Fouchereau Emmanuella in the laboratory CIMEOS, the University of Burgundy, and Fouchereau in a high school Hyppolite Fontaine, Canton, France. In introduction, we distinguish two pedagogical methods: direct instruction and active learning. Direct instruction is based on a structured pedagogy and is defined here as explicit teaching. It's based on a systematic instruction too. The large-scale students show direct instruction is superior. Again, active learning is based on the model of constructivism, based equally on spontaneous needs and the natural interests of each individual. It promotes freedom of expression and creativity. The acquisition of knowledge occurs primarily through action on objects and individual self-expression through their bodies. So, what perspective impact do they have on science education? Is there pedagogical practice which gives better results than the other in terms of scientific knowledge? A number of indicators have been identified to classify activities as direct instruction or active learning. All activities for which information is taught directly and explicitly without having to invent, create, or invest of himself a lot will be classified as direct instruction. All activities involving inventive or creative action from the pupil in which he is an actor to find some answer to a problem will be classified as active learning. This case today focus on a group of 29 primary school pupils that were collected following diagnostic assessment before the activity, and then through formative and final assessment consecutive to the learning activity. This evaluation enabled us to measure the knowledge of the pupil on two specific topics: racing and blood circulation, during 10 sessions in total. In the first results, we compare results of formative activities for direct instruction and active learning. Table 1 shows pupil success rates in formative assessments after direct instruction activities. Table 2 shows pupil success rates in formative assessments after active learning activities. For each one table, we can see formative assessment in percent and learning strategy involved for different activities. For example, in table 1, we have extraction of documentary, analysis of double entry tables, observation. Or in table 2, for example, we have analysis interpretation of video, observation, analysis, dissection. First of all, by comparing the two teaching methods, it can be noticed that with direct instruction, approximately 83% of the pupils succeed in tests, while active learning totals about 55% success during this formative phase. It is also important to note that activities during direct instruction involve many more memorization and organization strategies, while activities in active learning mainly involve organization or development strategies, as well as conceptualization strategies. On the other hand, we observe that activities are less successful than when they call up organization or development strategies. Indeed, by classifying the activities depending on the growing complexity of learning strategies involved, we could propose a correlation with pupil success rate. The more complex and developed the learning strategies being mobilized are, the lower the pupil success rate. Memory activities reach a high success rate in comparison with more complex activities of organization development, with a gap of more than 30%. In the second time, we compare the results between the initial and final assessment. Table 3 shows pupil success rate at the beginning and at the end of the second on bracing. Table 4 shows pupil success rate at the beginning and at the end of the second on circulation. For each table, we have initial assessment, final assessment, and pedagogy mobilized by activities. First, the evolution in knowledge at the end of the second for these two teams shows the positive effect of the training sequence. By analyzing the results of the active pedagogy between formative and final phases, it may be noted that pupil success rates in formative activities of dissection and video evaluation are very low, while in the final assessment and circulation, these activities have a very high percentage success rate. Again, results of the direct instruction activities in final phases show a low difference with percentage success rate from formative phase. We can propose that during active learning, summary writing activity, that especially some of the memory and organization strategies as in direct instruction, could explain the high success rate in final phase and this high difference. This study, in addition to previous studies carried out on the subject, show that memorization strategies are mainly present in direct instruction, while active learning seems to develop mainly more conceptual learning strategies. The pupils' most successful activities are those that call upon memorization learning strategies, whereas knowledge from activities that are based on more complex strategies seems to be less assimilated during formative phase. Weinstein and Meyer report that these complex strategies, which are not used spontaneously before the age of about 10 years, can be taught to 9-year-old pupils with a positive impact on learning. This low success rate is certainly correlated with the complexity of strategies mobilized, but it also may be associated with education that doesn't allow the recurrent cognitive commitment to this kind of a strategy. Nevertheless, our results could also point to the necessity of memorization phase during development and conceptualization that may facilitate these more complex phases. This could better explain pupil success rates at their final assessment about blood circulation. The summary writing activity, written before final assessment but after formative assessment, could favor the acquisition of knowledge and thus its mobilization during the final assessment. It could create a link with conceptual strategies used during the formative phase and the fact that pupils are less likely to succeed in doing conceptual strategy-based activities. UNESCO studies based on more than 10,000 students show that explicit instruction is far more effective on performance than active learning in the long term and on very different age groups for both primary and secondary school pupils with difficulties. In conclusion, our research on these results questions the potential effectiveness of active learning and the role played by direct instruction in the learning process. Isn't direct instruction a necessary part in the acquisition of knowledge, even though active learning could develop capabilities and the acquisition of attitudes? We could propose that neither of the teaching methods seems better or worse than the other as often explained, but both could be necessary in learning science in different phases that must be identified. So, knowledge or performance shouldn't be the only assessment indicator, but competency and transformation of conception could also be an interesting approach. Another educational model based on a new theory of learning seems to be an attractive alternative which integrates these two different pedagogical methods. Jordan proposed that research should focus more on change in students' conception. It could be a new viewpoint to change the teaching of science. Thank you very much.